But without further ado, I am going to start talking about something that I've known about for a long time. Oh, and it's not something that most square dance callers know. I've given the talk to our home association. I've given the talk to a group of round dance cuers locally, given the talk at Collar Lab, and it's came about. My knowledge of this is because I tend to be very careful with the money that I spend. And when it becoming a caller, I decided I was going to not pay hundreds of dollars for a yak stack, which everybody else thought was the ultimate thing. So I started researching as an engineer what it was, what it takes to, why yak stacks, what it takes to create a good speaker, a good enclosure, so I could build my own. And a friend had built his, two of them, finally two stacks, not yak stacks, and he sold them to me for $10 or something like that. And I was using one in a hall one time, and nobody could hear what I was saying. It was pretty obvious. And somebody said, "Well, I've got a yak stack in the car. Do you want me to go get it?" And I said, "It can't hurt." And quite the opposite. All of a sudden, everybody was able to hear me, and we ended the last 90% of the dance really nicely. So I finally decided it was time for me to spring for the magic of it. But I'd done a lot of research, and I ended up going one of the people that, the guy that designed, what am I trying to say? The Yak Stack was a 3-person venture. One was the designer builder. His name was Irv Gross. One was the marketing man, because he was very popular in the square dance industry, and that was Ed Ross Smith. No, excuse me, Earl Johnston. And one was the businessman and also took the orders and sent out the things, the yak stacks, and his name was Ed Ross Smith. I knew all three of them. Irv as a dancer, and again, trying to save money, instead of having Ed ship it to me, I thought I would save the shipping by not going to him. But Irv lived about 5 miles from me, so I got permission to go over there, and originally heard that the design of the yak stack was such that it folded and fit in Earl Johnston's trunk. Well, that was all bunk. That was just the rumor. But I ended up spending an hour or two talking to Irv, and finding out his background, and seeing his shop, and finding out that all the design things that went into it were everything that I had found out researching, and then lots more. And I'll get into a little more of that later. So let me start by, or maybe I won't, or maybe you'll ask questions. But the man was overqualified. Well, not overqualified. Nobody's ever overqualified. Let me tell you a little about Irv right now. Irv was a very quiet, laid-back person. His wife was the outspoken one in the family, and she was the one most people knew, most callers knew, because she made herself known. They were both very good, very active dancers. But Irv worked for a company named General Radio. I'm not sure if they still exist or not, but they made all sorts of electronic test and measurement equipment. One of the things they made, if you can picture when Radio Shack had these little handheld audio meters that you could listen from different parts of the room and see how many dB the sound level was at that point or ever. Irv was the guy that designed those at General Radio initially. They had anechoic chambers to work in. I'm not sure if you're familiar with what that is, but it's basically a huge room with so much soundproofing around the outside that when you walk in, something's missing. It's basically any kind of background noise whatsoever. So that if you test a yak stack in there with one of the sound meters, you can tell exactly how loud it is at different points, what the dispersion is. And Irv used the General Radio's anechoic chambers and his newly invented gadget for testing the patterns. And when he designed the yak stack, he was a fellow in the Acoustic Society of America or some such thing, etc. Well qualified for what he did. And anyway, I think partly I was killing time. Hopefully people would find the right link. One more sip of coffee and we'll go into sharing my screen. I would like to apologize to Dan, and I forgot who the other person was, but people posted some links under the invitation to coming here about good videos or articles online for some of the information on designing column speakers. And I haven't researched this in a long time. I didn't have time to look at those. So my apologies for not following through on your ideas, but I do plan to do that because they sound interesting. And even though some of my information is outdated, the physics of what's going on doesn't change. Our understanding of the physics does, our ability to design around it does, but the basics physics doesn't change. So without further ado, this is the screen I want to share. Oh no, where did this go? Oh, that's all right. Shh.
I am seeing understanding column speakers with an Escher-esque logo up on the upper right and a blue and a menu bar across the top, or a window title bar across the top.
Yeah, that's what it is. I'm doing two monitor thing so I can see your faces too, and I had something else pop up saying you're on Zoom. Good. Now I can look at you guys, or I can look at the screen that I'm talking from, and you're thinking, why is he looking away? The Escher-esque logo is one that I created, in the mid to late 60s, and I enjoy putting it and showing it off wherever I can. So we have the screen up. Let's see if the I do have to go to view. Yeah. Sorry about that. It should say slideshow someplace. Where is that? Slide only. Play. Oh, play. Play slideshow. There we go. Should take up more of the screen now, Dan. Is that correct? Do you see any of the people? Because I do. Anyway, so without further rambling, we'll go into the formal rambling. This talk is about column speakers. Good morning, Lars and Hannah, or good afternoon for you guys. This is about column speakers, understanding them, and it's not the usual stuff about, make sure they're in phase and make sure, you hook them in parallel or series or all that stuff. This is how they work and why we use columns versus other types of speaker systems. It's presented, presented by yours truly, and all that stuff. I'm not sure where I came up with this quote, but I love it. Some people learn by being told what to do. Others learn by understanding why they are doing it. I'm one of the type of people that I don't learn things very well until I understand why, and then I kind of recreate them in my mind. This talk is for you guys that like to understand what's going on. But it's also useful for you guys that are being told what to do, because I'm going to tell you what to do, how to set up your hall, and understanding or not, trust me, it works.
You left the third one out, which is the kind of people who learn by accidentally blowing shit up.
That's the next slide, Chris. So anyway, why listen to Don Beck? He's only a square dance caller. Well, he's also a mechanical engineer, a ham radio operator, which gives him a lot of electronics background. He's been an audio enthusiast for a long time. Combine them all, and you end up with a square dance caller. So we're going to get into the basics first. We're going to talk about what sound is in a very superficial but understanding way. What is a loudspeaker? What is a loudspeaker system? And in particular, the system of column speakers, what that's all about and why. So what is sound? Basically, it's something that produces vibrations in the air. Vibration, if you have can you see my cursor too? I finally figured out how to do that. Yes, good. So if we have a point source of sound here, basically it's compressing the air, and then it's giving you rarefications. In other words, pushing out, pulling in, pushing out, pulling in. And in doing so, that eventually hits your ear and pushes it back and forth, which your brain nicely converts to what we hear, how we respond to that. The main thing here is a point source of sound radiates sound equally all the way around. What is a loudspeaker? This next slide covers 2 or 3 things, and it doesn't show the speaker as much. But if you look at the center here, we've got a point source of sound, and here's it used to be a paper cone, a cone made out of paper. Now I think they use plastics and other flexible material. It's actually mounted on flexible stuff. It's got a big magnet in the back and an electric coil, and the electric signals go through that coil and make the coil move back and forth in accordance with the audio that we're listening to. So the cone basically moves back and forth, causing these compressions and rarefications. Interestingly enough, because of the physics of the world, the backside of the cone is doing the same thing, interfered slightly by this magnet, but the backside of the cone is doing the same thing. When the front side pushes, the back side is sucking air back. When the front side is pulling and giving the rarefication, the back side is pushing. I mean, you can picture the cone going back and forth. One side does one thing, the other side does the other. You've heard the terms in phase and out of phase. That's what we've got here. The front and the back are out of phase. When one's doing one thing, the other's doing the other. And if you have the opportunity just to get a small 4-inch speaker or something, and without any baffling or anything, and connect it up to a sound source, you'll actually be able to, if there's low enough notes, you might see the cone moving back and forth. But if you touch your finger on it lightly enough so it doesn't damage, you'll feel it vibrating. There's a buzzing going on. But what happens is the front and the back being out of phase will tend to cancel each other. If you take a piece of cardboard and just cut a hole in it the size of the speaker and just place it against it, and this doesn't have to be very long, 2, 3, 4 inches, you will hear an amazing difference in the sound by just isolating some of this front from some of this back. When I've done the talk live, I've had the equipment there to do it where you can actually hear it. One of the reasons I haven't given this talk here sooner is I was trying to figure out how to rig it up live, and I just didn't want to go through the work. So you'll have to take my word for it, or better yet, do it yourself. But anyway, the baffle does isolate the front and the back because they're out of phase. What is a speaker system? Speaker system is the speaker, the baffle, the cabinet it's in, and the cabinet, we usually put it in a cabinet. Some of the old calling systems, Newcomb and such, the cover of the case that fit over the turntable had a speaker in it, and it was an open back. So the sound, was somewhat baffled from the front, but not completely. Not enough, really. So people put boxes around it to enclose the back sound. And what would happen is that the sound would hit the inside of the wall, then bounce back and interfere with the cone moving back and forth. So if you open any modern speaker system, modern cabinet, you'll probably find some sound damping material in there, foam rubber or fiberglass or some such thing. And that's so that the sound off the back of the cone gets absorbed rather than bouncing back and interfering with the movement of the cone. Typical types of speaker systems, just a simple box. There are things called folded horns, bass reflex, columns, etc. And I'm not going to talk about all these and say what the pros and cons are, but just they're terms you may have heard, and if you have questions about any of the others in the discussion part, let me know and we can talk about them. But things like the bass reflexes some of these folded horn or the bass reflex, they're intended to have good sound in your living room. Yak stacks are not great, and I'm talking stacks in general, but I'll say yak stacks frequently because that's what I know and use. And I'm talking about the originals. It's changed hands 2 or 3 times, and the outside case looks the same. I'm hoping the inside still has Irvin's hard work in there. Yak stacks are not great hi-fi speakers in your living room. They're not designed to be. They're designed for something else and sacrificing some of the high fidelity. And we'll see what that is in a second. So, lastly, column speakers. Let's get down to business here. Looking at a column speaker from the top, we showed you what a point of sound will do. It has wide dispersion, and when you look at it from the top, it's effectively a point source. And the dispersion, or the area that we talk about, is actually down 3 dB from where it was, is fairly wide. And it's hopefully that not only the squares in front of you can hear, but the squares off to the side that want to be in the front of the hall but can't get right in the middle. It's got a fairly wide dispersion. That's what it's all about. But the design of the column makes it so that looking at it from the side, the vertical dispersion, let me try that again, the horizontal dispersion. 3 cheers for a spell checker too, because that helped me get dispersion correct. The horizontal dispersion is narrow, it's focused, it doesn't go up all the way. And what does this mean? Well, it means it focuses its energy where you want it. More importantly, it means it doesn't have an equal amount going up and bouncing off the ceiling and coming back. What did you say, Mel? 20 milliseconds, or Dan? That causes enough confusion. But when stuff goes up bounces off the ceiling and comes back down, it causes distortion when they're getting it straight. There's echo effect, etc. It's also not wasting energy bouncing off the ceiling. Same with going off the floor. There's no sense sending stuff down to people's feet. It's focusing the energy where the heads of the people are. And I didn't draw little heads in, but I was going to on a further, on a system that's further back. It aims it towards the back of the hall. So let's continue on from here. How does it do this? How does it focus the energy? This is the part where we get a little bit technical, but it really helped me understand what a column speaker is all about. So bear with me and absorb this. Wake up, pay attention. I've got a column of 2 speakers here. I've got the same diagram that I had with 2 point sources, and I'm looking at the side of it. I've got the same compression rarefication coming out of each speaker. And because they're offset and it takes a while for this sound to get up to this, in some places here, the compression of this speaker is going to coincide with the rarefication of this speaker, and they're going to cancel each other. That's what gets the sound so that it's not very focused up front, up at the top. But going straight ahead, those 2 compressions reinforce each other. This is the darker part. So you've got concentrated sound or reinforced sound coming out of the front, and out of phase canceling sounds coming out of the top and bottom, which gives you that, do we have that before? Which gives you that pattern here. It's canceling down here, it's reinforcing out here. This is the best I could do to demonstrate it, but I think if you have faith, it shows pretty well, and I can't quite make it bigger if you can't read. Speakers cancel each other up here, speakers reinforce each other here. You can see the darker. That's the whole deal of why a column speaker has wide dispersion, which we want vertically, and horizontally very focused dispersion. Now, let's look at some technical stuff. And I didn't get into the actual equations, but if anybody's interested, I can dig them up. But the amount of focusing depends on the length of the column and the frequency of the sound. Higher frequencies need a much shorter column. If the column is too long for the high frequencies, it focuses it so much that you've really got to aim it at the heads of certain people instead of in general. So you really need a fairly short column for your high frequencies, or else it's focused too much. And for your low frequencies, which tend not to be as directional, you need a longer column to keep them from dispersing too high and getting all the powers there, lost in there. And we'll talk about that later. Okay, so how do you get a happy medium? What's the happy medium of compromise between too short and too long? Unfortunately, there really isn't one. I think that I forgot 1,000 cycles. I looked at this yesterday. I didn't want to get in this technical. Was about a 2.5 foot speaker column, and anything longer than 2.5 feet was going to get the high frequencies much too focused. So what's the solution? You use different length columns, right? You have one for high frequencies, one for low frequencies. But why do we all have a single column? Well, at least how YakStack does it, there are 6 columns, 6 speakers in the column. There are 6x9 speakers, oval oriented vertically, so you get longer length and less width, so it's more of a point source sideways. But the center 2 speakers have, well, the way you usually get high frequencies, you need a larger speaker for low frequencies, and you need a smaller speaker for high frequencies. The typical way people do is, you've heard of tweeters, where they put a small speaker inside mounted inside the other one, so you get the high frequency sounds from the tweeter. Well, it turns out tweeters are expensive. They're more coils, more electronics going to it and everything. And so the less expensive way that Irv chose to make it so the cost of yak stacks wasn't out of this world was to use what was called a whizzer cone. They would put a very small cone in the center that projected the high frequencies much better than the low frequencies. And so what he does is the center two speakers, the bottom of the top half and the top of the bottom half, form a 2 or 3 foot column in the middle that does the high frequencies, the whizzer cones, and the full length to get more bass, more place for the large speakers to move in and out further for the bottom ones. The speakers that Irving used were made by Utah Speaker, and he had them made, custom made by Utah to provide the whizzers and the identical matching non-whizzer things. It wasn't an off-the-shelf thing. Again, I have no idea what is happening with the current yak stacks or other column speaker systems, but this is the way the yak stack used to work, and again, the physics are there. Let's see. What about half yaks? People use half yaks. I can get away with sounds from here. Well, it turns out if you take a stack and break it in half, you don't have the bass because you don't have as much of the large moving stuff, but you've also cut it down to one of the whizzer cones. You've shortened the high frequency column considerably, cut it in half, and so it doesn't have near the focus ability at the high frequencies. High frequencies tend to be more direct, and whereas low frequencies are not as directional. So if you are going to use half of a yak, use the bottom half so that the top speaker is the one with the whizzer cone, so that the top speaker isn't interfered with as much by the people and such, so the top speaker of the half yak. If you're going to use the top half, turn it upside down so the whizzer is on the top of that half column. It doesn't have nice feet, it has hinges you're going to grind on. But a true half yak, and I think this is what Irv did when he sold half yaks, and I hope they do now. A true half yak is not half of a yak stack, it's half of the cabinet, but it has two speakers with the whizzer cone, 2 whizzer cones, the top 2 of the 3 column stack. So you have the full high frequencies have the full length they need for focusing, whereas even though you don't get the full bass and you don't get the full column length for the low frequencies, at least for the high frequencies you can have a full stack. So you get full focusing for that. So again, I'm not sure what they're doing, but hopefully that's what they do with it if they sell you something called a half yak without hinges, just feet on one side. Knowing all that stuff, let's talk about speaker placement, how to get the most out of what you've got. One is when you set up your system, and I don't think I worded this right, project down the hall, versus across. I think I've changed the wording. You want to be on the, if at all possible, and hopefully the stage is there at the short end, down the long end of the stage, where against the narrower wall. That way, you don't have as wide a projection dispersion as you need if you're working from the side of a hall, because the walls are closer and people can't be that far away, and you're spitting the sound straight out. Whereas if you're on the short side, if you're in the middle of the long side of a hall, the other side of the hall is a lot closer, and you're just going to get sound banging, reflecting off of that and coming back at you, and interfering with the echo off the back. Don't split your yak in two. I've seen people where they'll put half a yak on this side of the stage and half on that, figuring they're getting better coverage. Well, two things. One is we're playing with a half yak. One's got the whizzer on the top, one's got the whizzer on the bottom, so you're getting different sound. And two, you're somewhat creating a column between those two. Yeah, the sound on the left and the right, and at some point in the middle, they're going to cancel each other, and you're going to have a dead spot in the middle. Talk more about that soon. But the main reason is all this hard work of getting this long column to focus the sounds, and you're cutting it in half. You're not using what you paid for. I've gone into halls where they've had a program going before, or it's a hall that has dances regularly, and where the club or the club caller has set up the sound system already, and I don't have to set up my own. And they've got two speakers up there. And literally, I've done this where dancers have come up and said, I'm having troubles hearing. Can you point that other speaker a little differently, or can you point it at my square, or what have you? And I'll go over and fidget with the speaker, and then everything gets all fine, and everybody's happy and can hear. And basically what I've done is unplug the second speaker. One speaker is enough to cover it. Two speakers interfere with each other and give you dead spots in the middle, where the sound's out of phase and they cancel each other. Two speakers, unplug one of them. And I've never had the chance to do this myself because I haven't had two yaks myself, or where I've worked with more than one yak, it's been somebody else setting up the hall. But really, if you need to have two yaks and want to cover, need really wide dispersion, put them right up there next to each other so they're close to being a point source, and then aim one off to the left and one off to the right. And you should have much less distortion and cancellation in the center and get your proper projection off to either side. Mel, this sort of contradicts what you were saying before. You stand in the middle but have them off on one side or the other. And you haven't had trouble, so if it works, use it. But give this a try sometime and see what you think. And don't stand between them because they're too close to each other. You'll get squished in there. Swish. So here are some do's and don'ts. If you're using a yak or any other column on your table where you're calling, put it on the edge of the table. Now, my apologies, these were supposed to be sound waves coming off, and instead they look like the wires and cables behind it. But really, this is the front of the hall. The dancers are over here, and I should have put little dancing stick figures here, but I didn't. So don't think of these as the cable. Think of it as the direction the sound is coming out of. But think about the pattern we're trying to get out of this speaker. And, you want the proper cancellation from the speakers down here to the speakers here to the speakers here. So don't interfere with the pattern. Put this right at the edge of the table. A lot of people put their speaker way back here. I can hear it better. Tough. The dancers can't hear it as well. The table here interferes with the pattern of the speaker, and you're not going to get the proper focusing. If you can, use a stand. That way your speaker is totally in the clear. I learned this. The big difference on this is one of the clubs that I called for regularly for 18 years used to give me a Christmas present. And one year they gave me a stand for my yak stack. And I figured, oh, this is nice. I'll have more table space and it's not as likely to tip over and everything. All of a sudden the sound improved. It made a big difference. If you can, put it on a sound and let this have all the room it needs to play for the canceling effect and focusing effect of the sound. The next thing is, if at all possible, tilt it slightly forward. The yak has a bracket here which naturally lets you tilt it. I had a special bracket made for me that allowed even a little bit more tilt. And what I try to do is tilt this at an angle so that I don't want this bouncing off the back wall and coming back. A lot of halls you'll see people are dancing great all the way up, and the last square is doing great, but the one square in from the last square is having troubles. And having troubles dancing basically means they're having troubles hearing. And that one square in is getting the bounce back from the back wall. The back squares is pretty much the bounce back is in phase, and so they can hear. But the one square in frequently has a bounce back that cancels what's coming from the front, and that's where they have trouble. So I like to tilt this a little so it's not, if it does hit the back wall, it bounces down. The way I do it is I've got a little, there's a little crack between the two halves of the yak. I will use that as a sighting thing and aim it to hit the spot at between the wall and the floor. The other thing that does, and I didn't show a good diagram of this, but if you want this above the people's heads, but the pattern is here so that the front of the hall people are towards the side of this reinforced sound, and the people in the back are in the middle of it. So the people in the front aren't blasted away. They get about the same volume that the people in the back do. They're closer, but they're not as much in the center of that focused beam. What was I going to tell you next? Oh, beware of obvious obstructions like a basketball net. You go into a hall, especially if it's a gym, obviously, and there it is. You're on stage, and there's this big basketball backboard. Not only does it bounce the balls off the front, it bounces the sound off the back. If at all possible, request that the club president tell the janitor to crank this thing up out of the way. Some of them are electric, and they do that. Others say, oh, no, that's too much work. I got to crank and crank. Some of the club members will do that for you, knowing the sound difference. But if you can't get from that, go to the side of the stage. Work around the corner, not just directly behind the basketball obstruction, the backboard obstruction, but off to the side. And I like to go as far to one side as possible. I happen to stand on one side of the table instead of in back like some guys do. I happen to stand on the right side. Most people do with the left, but if I'm on the right side, I move the table all the way to the left and the speaker further left than I am, and aim it towards the far corner. So you're eliminating the bouncing off of the back walls, and you're getting away from this obstruction. This obstruction not only kills sound for people up here, it distorts the pattern that you worked so hard to get. There's some not so obvious obstructions. If you're on a stage, there's frequently a cornice hanging down from the curtains on the side, and that cornice actually interferes with the pattern. It's not always obvious. Sometimes that's pretty close to the front of the stage, and if I try to move the speaker forward, my yak is going to fall off the stage, but I will sometimes just drape the cornice over the back of the thing. Let's take a look at that. But, I'll move it forward of that. One of the things we talked about earlier is callers say, well, I like the speaker on the back of the table so I can hear it. Hopefully you can do what you should do instead of moving the speaker back as you move forward. Hopefully there's enough stage there so that you can move slightly forward so you can hear the sound also. One anecdote where this made a big difference, our Callers Association used to have a once-a-year dance for up to 2 couples from each of the local clubs to showcase our newer callers. And we had one gentleman in the club that was our sound expert, knew all sorts about, of course, he knew about everything, and he'd be willing to tell you about it. But he set up the sound for that dance. And I was, it's one caller at a time, so I wasn't calling most of the time. I was just walking around and watching and listening. And I was watching pretty much the back half of, we had maybe 15 squares there, I don't know. And it was a fairly narrow, long hall, which was they were set up at the appropriate end of that. But the back half of the hall wasn't doing very well dancing, just the front half was. And I went to the side back left corner, and I slowly walked along the sides towards the caller, or towards it was more of a platform than a stage, very low stage. And I could hear garble, 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 and all of a sudden clear sound. And it was very obvious about halfway down the hall, the dancers were just not able to hear, and that's why they weren't dancing as well. Lord forbid I should tell this guy that he set something up wrong, but when he wasn't looking, I moved the speaker about 6 inches forward, just in front of the cornice. And for the rest of the dance, everybody was hearing fine, and the whole floor was dancing properly. It makes a big difference, just that little bit of a thing, so beware of it. In summary, use column speakers not for the quality of the sound, although the quality of sound is good, and some of the columns may provide that also, but you're basically using it for the projection to keep echoes down and point the sound the way you need it. Now, if you're outside, you really don't care. Hilton's used to say, oh, we'd cover 300 squares with these big booming box speakers. And yeah, they did. And they had to boost a lot of energy into it because they were wasting a lot towards the sky, but at least it wasn't bouncing back off the moon and interfering with the dancers, so they sounded fine. You just had to pump more power into it. But it was wasted power. You want the columns, because of the projecting, be sure to use your column vertically. I've seen people put their column horizontally on the edge of the table or something so that they would be able to get sound on this side of the hall and sound on that side of the hall also. All they were doing was defeating the total purpose of this and projecting into the ceiling and floor, but focusing it narrow so you weren't getting the corners of the thing. Be sure to use it vertically. Place it at the long end of the hall, again at the narrower wall, so you're projecting down the hall, not across it, so the wall that's reflecting back at you is further away, not close. If possible, use a stand. If not, at least use the edge of the table. Don't let that table interfere. Now, I used to use the edge of the table. I didn't use the stand always, and I used to tilt the speaker forward. Now, how do you tilt the speaker forward without the liability of it falling on the floor or, worse yet, on somebody's head? I would stick something, maybe a half-inch rubber eraser under the back, but I used some parachute cords, some 1/8-inch nylon line that I would tie to the handle and tie to the very back legs of the table so I could keep it from falling forward. It made the sound better. It would freak the people walking by out because all they would see was the speaker leaning forward, and they said, watch out, that's going to fall. But it made the sound better, and that's one of the little things I'd carry in my toolkit is 10 feet of parachute cord and a rubber eraser. And lastly, avoid obstructions, cornices, backboards, what have you. And with that, I think I tell people not to talk more than 35 minutes. Not only did I have a more formal presentation, I went over my time limit. So let me stop sharing if I can figure out how to do that. And